on.
Yes, good afternoon, good evening, dear colleagues. On behalf of the project organizing team, I would like, first of all, to thank all the participants contributed to this project for really valuable contribution, which resulted in the draft report, which was prepared and distributed between all the participants. You remember that this report should be something like a formal ground for policy recommendations on behalf of APEC for economies. And this policy recommendation should support the smooth and fast implementation of this new technology in the region, in the economy of APEC region, of the APEC region. And I would like to add that currently, importance of this activity of this project is even more rather than in the very beginning of our project, because we see very fast, extremely fast development both of technologies in the industry and international regulation in the International Maritime Organization. Just recently, last 2 weeks, I participated in the working group of the Maritime Safety Committee of the IMO, where autonomous navigation was one of the key topics. And I would say that work of the working group of the MSC and previously joint working group of MSC Legal and Facilitation Committee of the IMO on the autonomous navigation regulation was very successful. There is more or less a common understanding of major principal points. There is a progress with the development of mass code, which should interpret and add some complementary provisions to cover potential gaps in implementation of autonomous ships in commercial operation globally. And definitely shows that the timeline of the IMO regulation implementation will be met. That means that next year the mass code will be developed, and starting from the 1st January of 2024, it will be implemented first as a non-mandatory instrument, and starting from 2028 as a mandatory instrument. So we see that this development is very fast. And the autonomous navigation is not just an abstract future. This is something which will become the reality of our industry very soon, just in a few years. And what we see during preparation of our report, we see some obvious risks in imbalance in access to this new technology between different economies of the region, and we understand that we need to develop recommendations, we need to develop policy recommendations, how economies of our region should utilize opportunities, should mitigate risks associated with this new technology to be competitive, to keep competitiveness of the APEC region and of every economy of the APEC region. Because this new reality definitely could change many things in the maritime industry. So I would like to encourage you today not only present and discuss ongoing activities in this area, but also to propose, to advise your vision, what should be done, what we need to do to bring this technology to the APEC region economies, to make the APEC region really strong and leading in the implementation of this new technology. Here, I would like again to thank everybody for the participation, previous participation and today participation in the work on the project, and pass the floor again to Evgeny.
Thank you very much. Let us from the beginning make some conventions. If you have any questions after any speech, after any presentation, you can ask the questions just from your spot, just to take a micro and ask the questions. If you have the questions that need to be discussed more deeply, we'll have a discussion session after all the presentation where we can discuss in depth all the issues of your interest. And now let us go to the first part of our meeting. It's about the exchange of national experiences, and we shall have now a speaker from Russia, Mr. Vladimir Teterev from Federal State Unitary Enterprise Rosmorport, who will let us know about the best practices in Russia on the implementation of the autonomous navigation. Mr. Teterev, good afternoon. Please take the floor, your micro, and we are attending your presentation, please.
Good afternoon, dear colleagues. I'm switching on my presentation. Okay, I'd like to say a couple of words about my company. I represent Rosmorport. Rosmorport is a state company responsible for the development of the infrastructure of Russian merchant seaports. The company maintains the depths of port of aquatories, provides building and operating of berths, shipping channels, coastal and floating aids of navigation, GMDSS coastal radio station, systems of vessel traffic service. At the same time, Rosmorport is the largest Russian ship owner. Our company operates about 300 vessels, including 37 icebreakers. The company owns vessels for rolling cargo, tugs, dredgers, pilot vessels, and other types of ships too. We consider autonomous navigation technology as a many promising technology of the nearest future. We expect that a navigation technology can be a key of reducing the risk of navigation and fleet operating costs. It is why we are taking part in testing autonomous navigation system. And are trying to solve the following tasks. Creation of new ship and shore hardware and software, broadband ship-to-shore data transmission, big data processing, including cloud technologies and artificial intelligence. We have a number of aims of the project. Some of them are to get the experience in the creation and operation of autonomous vessels, to take a part in national legal regulations preparation, to construct the infrastructure for autonomous navigation, training of specialists for the operation and management autonomous vessels. We have started with remote and autonomous navigation experiments with 2 small dimensions vessels at 2019. These are the dredger Redut and the SCO Рабочие. Remote control unit had been installed on board of the dredger Redut. In autonomous mode, SCO Рабочие can move according to the road given by navigator and without navigator's help to provide the divergence with other vessels. Divergence algorithms are offered by several Russian universities and companies. At the beginning, the main problem for the remote control of SCO was the provision of reliable broadband data transmission channel between the dredger and SCO Рабочие. The next step will be installation on board of RoRo vessel Marshal Rokossovsky autonomous navigation system. Motor vessel Marshal Rokossovsky is a modern vessel with a high level of automation and twin fuel engine with ability to run on diesel and natural liquid gas. The ship operates in the Baltic Sea between ports of Ust-Luga and Baltisk. We are in the process of installation of remote control and autonomous navigation facilities on board of motor vessel Marshal Rokossovsky now. The remote control center will be established in St. Petersburg. In the same time, motor vessel Marshal Rokossovsky will be equipped with software and hardware so that it will be able to provide 3 modes of ship's navigation in Baltic Sea. The first, the mode of navigation assistance for the crew. It means that the new facilities will be able to provide the navigation advices to the ship's mate on the bridge. The second, the mode of remote control of ship from the center in St. Petersburg. The third, autonomous navigation mode. It will be done possible the navigation at deep sea without participation of crew members at all. The set of training programs for MAS personnel were approved in September 2022. The programs are based on applicable standards and practical experience of autonomous navigation. The purpose of the training programs is to prepare captains and crew members to operate by semi-autonomous vessels and the external crew to operate by fully autonomous vessels. For providing crew members training courses, the simulator of various navigation conditions and scenarios has been developed. The simulator based on an open platform for virtual simulation of autonomous navigation, developed with the framework of Marinette in 2020-2022. 42 specialists have already been trained now. The sister ship of Marshal Rokossovsky is motor vessel General Chernyakhovsky. Will be equipped by a navigation system this year too. Marshal Rokossovsky and General Chernyakhovsky will be certified as MAS under regulation of classification of maritime autonomous and remotely controlled surface ship issued by Russian Maritime Register of Shipping at July 2022. Both ships will be able to provide navigation under manual control and remote control when moving at sea. Manual control with the use of navigation system for decision support when moving in restricted waters and at the entrance to the port. Full autonomous mode when moving at deep sea. Thank you for your attention.
Thank you very much, Mr. Teterev, for your presentation of the national experience. I think that you have well introduced the mode of introduction of the system into the practices, all the stages of this process, and some problems which accompany the implementation. For instance, communication problem, and also what is very important, the training. Thank you very much. And dear participants, if you have any questions just now, please ask your questions to Mr. Teterev. If there are any questions just now, please. I don't hear now. Probably you will be you will think about your questions, and you will be able to ask them later on during the discussion session. Thank you, Mr. Teterev, for your presentation. Thank you very much. And now I would like to ask Mr. Han Kim from Citronics to make his presentation. You're welcome, Mr. Han, and the floor is yours, please.
Thank you.
Yes.
Thank you for inviting for this meeting, a seminar. So, hello, I'm Han Kim, the CTO of the Citronics. So we are developing artificial intelligence and robotics-based situational awareness technology as a member of the CAS project, Korea government lead autonomous ship development project. So today we would like to briefly explain the CAS project and introduce the technology we are developing. Starting with the Mooning project, several projects to develop marine autonomous surface ship called MAS are underway in each country. So Korea is also developing MAS at the second and third level of autonomy from 2020. The CAS project started relatively late compared to the other project, but the goal is to satisfy the IMO level second and third by verifying functions such as remote control, including situational awareness technology, targeting actual shifts for the remaining 2 years. In the CAS project, we are involved in the development of the situational awareness technology. For the implement situational awareness function, we can consider the sensor system include radar, automatic identification system, camera, and LiDAR. For each sensor, we can summarize whether it can meet the function as follows. In the case of the AIS, detection, recognition, and identification is possible for ships that transmit their location, but not possible for the ships that are not equipped with the AIS transmitter. In the case of the radar, it is possible to detect, but it is difficult to distinguish the type of object without the help of the other equipment. However, it is possible to continuously track a specific object such as an ARPA radar function. Camera is widely used sensor that can perform all functions and can detect light affected by environmental factor. But they are passive sensor and highly affected by environmental factors such as light level. LiDAR is a laser-based three-dimensional ranging sensor, so it can detect objects in the vicinity. Recognition and identification can be difficult depending on the detection range and the LiDAR specifications. As each sensor has its own shadow area and pros and cons. So we develop a solution that can overcome the disadvantage of each sensor to estimate the object information. By fuse the object information, we can respond to the lookout function. In conclusion, existing system or configuration cannot satisfy implementing the lookout function. We are continuing research and development to implement lookout function with the artificial intelligence and robotics-based sensor fusion technology. Our solutions are structured to complement to fuse the capability of each sensor to continuously generate situational awareness information with no shadow area. Our design and research capability have yielded the following results for each sensor. The following video demo is the recognition algorithm based on the camera data. We design our own artificial intelligence model that runs in a real time on an embedded processor to estimate the distance and speed of object recognized by the camera. To fulfill all functions, we designed to estimate the confidence value of the continuously tracked object. so that the performance degradation can be judged using the continuous tracking results and confidence value of the object. So we can meet all the function using the camera sensors. In addition, in order to improve situational awareness performance in complex coastal areas, the port side is also continuously verifying the performance of the recognitions. And confidence estimation for the lookout function. Next is an object recognition and tracking algorithm based on the radar data as part of the CAS project. Our technology classifies terrain and object in the radar images and noise caused by ship's attitude and environmental factors. In the case of the object, they can be tracked and assigned a unique ID. This algorithm also can estimate confidence value for each object. We also use the LiDAR sensor a little differently. Since LiDAR sensor can only acquire 3-dimensional distance information and have a limited detection range. So we use the LiDAR data to calibrate the ship's position and attitude rather than the perception, and to provide information for the local map generation for applications such as autonomous birding. Next, we fused all of the information generated by each sensor to integrate the situational awareness information. The result of the sensor fusion can meet all the functions, and based on the integrated information, we can safely navigate to the destination through the waypoint generation technology that satisfies COAG rules. In the future, we will gather more data to increase the reliability of our situational awareness technologies. We have the following roadmap for situational awareness platform. Last year, research and development was conducted to improve the reliability of our situational awareness technology. This year, we will establish the basis of the situational awareness platform by complying with the regulation of the mass code. From next year, we will expand our situational awareness platform through various products and collaborations. We want to innovate the maritime industry with our situational awareness technologies. So before we started designing our product, we thought about where is the situational awareness technology we introduced could be applied quickly. This slide shows the vessel locations in the port of Singapore, one of the most complex ports in the world. As you can see that the complexity of the area within the harbor is very high, which is very similar to the global situation. In conclusion, we recognize the port and their surrounding coastal area is highly complex and naturally have a high risk of the accidents. So we decide to prioritize solving the problem with our situational awareness technologies. Our first product, called Navis, can help the ship navigate berths and the narrow channels. It is a system that utilizes artificial intelligence technology to provide information on objects around the ships. The system has been installed on the test vessel of the CAS project and received very good feedback from the stakeholders. The second product is Avis for the smart ports. When a vessel is making a berth, fusion sensor module installed on the port can provide the distance and speed between the ships and the berths, also distance between the neighboring ships. The system is designed to be delivered all of the information through the cloud server so that the ship and its stakeholders can share the same level of the information. The solution is included the navigation support system as a part of the CAS project and can support the both conventional and autonomous ships. Since 2015, we are focusing on development of the situational awareness solution using artificial intelligence and robotics technology. As a startup, we can get an opportunity to lead change in the industry of the disruptive innovation through the enactment of the CAS. Thank you for listening.
Я смотрю презентацию, что. Could you please share your screen again? Maybe with some. We don't see your presentation. Can you show it again?
Yes.
Thank you.
So if you have any question, please questioning me and my colleague.
Yes. We don't see anybody to ask.
So anybody has any questions?
Well, I think that yes, we see something in the chat box. Can you see or I can read it?
So yes.
Yeah.
Yes. The first question is how are the VTMS we communicate with the mass vessel? Maybe it depends on the countries, the regulation, but in Korea, we will communicate with some national communication devices such as long-term evolution devices or the satellite internet. So all of the information through that kind of the devices, we transport the remote control center and the situational monitoring center. And second question is the applicable to the talk about. Yes, we are currently in the previous video is applied to the test vessel of the CAS project. Is the unmanned ship for is designed for the unmanned ship for third level of the autonomy for IMO. So and we also apply some such as the VLCC and tugboat also.
Any other questions, please? So, Mr. Canton, thank you very much for a very interesting presentation. So it was very focused, and that's why it can be further discussed if we'll have any technological questions probably during our discussion.
Thank you
very much. And now I'd like to ask somebody from our team to present the next steps of our discussion. I think we can have an interactive question or interactive exchange of views on the topic. Yes, Victoria will say something.
Yes. Good evening, dear participants. In order to make our workshop as much as interactive as possible, we prepared several questions that we will ask you during the workshop. And now I will share with you in the chat our first question. We would like to ask you to fill the form. You can click on this link and you will be redirected to the form where we would like you to answer the question. What would you like to learn more about implementation of autonomous navigation technologies? Your answers will be very useful for us because this information we will add to the study reports that will be finalized after our workshop that we are now currently developing under the ongoing project of APEC, and we would like to ask you to take active part in this questionnaire. So your feedback is very much appreciated. Thank you so much. And you also could answer this question online in the form, but if you would like to take the floor and to give your answer to us now, it will be also very welcome. Thank you.
Thank you. I think the question will be valid and you can fill in your answers till the next questions appear. Yes?
Yes.
So thank you very much. And now after exchanging the regional experience, we can now go to the discussion on the implementation of the autonomous navigation technology in Asia Pacific, on the current challenges and problems and best solutions and practices. So I would like to ask Ms. Kavita Fatmiasari, national expert from Indonesia, to present her opinion and presentation, please. Colleagues told me that Ms. Kavita Fatmiasari, for technical reasons, she could not join us, but we hope well that she will join us in a few minutes. So if it's possible, can we ask our next speaker to take the floor? We can go to the next presentation while we are waiting to Ms. Kavita Fatmiasari. I think that we can invite the representative of Chinese Taipei to present his presentation and his opinions on the development of the process of implementation of autonomous navigation in Asia Pacific and in the region. Please, if you are with us now. I'm sorry, are you ready to present now? We have a question here. Will the VHF radio still be useful in mass vessel? It's the question on our chat box. I think that we can ask our previous speaker, maybe, if he doesn't mind, Mr. Han Kim, to respond to that question about the use of VHF radio.
Yes. So yes, VHF radio still leads for the mass vessel because in the mass regulation, all of the devices have some own own coverage, and so depends on the some kind of the ability system for any situation. So the VHF radio still needed and still useful in mass vessel and on other systems, I think.
So thank you. It was a very short response, but very clear. Thank you very much. If there are any questions, shall I ask once again if the presentation of Chinese Taipei is ready? I say presentation doesn't mean that there should be a presentation itself, but presentation of your ideas and opinions on the topic. I'm ready now to take the floor. And we have another two questions.
Yes, the first question is AI don't use the VHF radio because the VHF radio has the small bandwidth transmit some kind of the information such as the images or other data, but artificial intelligence also some point of the needs some small bandwidth data that might be using the VHF radio, some specialized information for the degradation performance of the situational devices or other function maybe can possible, and almost the function of the situational awareness in running on the local platform in the mass vessel locally. So I think in some point of the VHF radio can use for the artificial intelligence. And second question, second question is also need for the mass ship, special devices. I think the need for the specialized devices for the mass ship. I think because the mass ship has level depends on the level of autonomy, but some kind of maybe third of the fourth level of the autonomy of the vessel, they burst the selfly burst, so it can be for the possibility for the bursting, I think. So in Korea, such projects, some kind of the autonomous docking system, maybe we develop for some kind of the company can prepare for the autonomous bursting for the mass, I think. Thank you.
The moment if Mr. Petrov is with us, I would ask him also to answer the previous question that you have just answered about the necessity to build up automated berthing facility. Mr. Petrov, if you are with us, what is your opinion to the previous question about the necessity to build an automated berthing facility exclusively for the mass ship? Is there is any need of that kind?
Dear colleagues, I think it's not exclusive for mass using automatic berthing facility. I think it's possible for usual ship too, my opinion on this.
Thank you. It's also clear the position is clear. Thank you very much, Mr. Petrov. And we have another question. Before I will give the floor to representatives of Taipei, because we see that they reconnected just now. But there is another question: if there are any future programs to respond to maritime distress Mr. Kantun, probably you can answer also this question.
So in Korea, any kind of the program to or any feature for the maritime distress not found yet, but maybe the next generation of the government project can consider this kind of the program or any feature, I think.
So, thank you. And there is another question. I think how many silent hours that mass already tested? Do any frequencies interference faced throughout sail?
So we cannot correctly check the sailing hours, the test vessel, but we are running on the 24-hour a day. So maybe we can check the all kind of the situation and tested equipment so very often. So and we focused on the coastal area because the coastal area is very complexity in the on entire navigation. So I think maybe next year we can apply to the real container ship to our situation awareness system that can be checked the entire navigation process and our reliability of the situation awareness and other equipment, I think.
And thank you very much, Mr. Kantun. And Mr. Tetter, can you also answer this question? What is your opinion?
You speak about interference frequencies, yes?
Yes.
It will depend from area of sailing. I think depending will be from method of data changing. So we hope to use satellite communication. I think we don't find some interference for satellite communications.
Thank you. And now there is another question. I'm sorry for our colleagues from Taipei because there are many questions. Thanks to the previous presentation by Mr. Kantun, the discussion is valid, and we all read the discussion of the questions. One more question. How are you going to deal with radar false target echo detection?
So we know the radar has always have the first targeting or the echo detection. So we use the fuse technology because the radar has some shadow area and first targeting detection. And using the artificial intelligence, we cannot make the 100% accuracy. So currently we fuse all kind of the data such as the radar and camera. So we filter some kind of the first targeting data and the other situational noise such as the wave or something like that. So basically sensor fusion technology can filter that kind of the noise and the first targeting on each sensor. Thank you.
Thank you really so much for your presentation and for answering so many questions. But I think it's very useful for all of us to hear different opinions and to answer the very necessary practical questions. So thank you sincerely once again, Mr. Kantun. And now I would like to ask to take the floor the colleagues from Chinese Taipei who are now with us. So please.
Hello, everyone. Good evening. Yeah, thank you for having us. Yeah, my name is Angus. I'm represent for Ship and Ocean R&D Center. Yeah, and today I'm going to share a presentation, yeah, about our progress, yeah, to apply the autonomous ship for our Love River located in South Taiwan, Kaohsiung. Okay, can everyone see my sharing screen clearly? Okay, so here is a briefing about our R&D center. Okay, we was founded in around 50 years ago, and we provide the ship design, and also we offer the technical service, yeah, to our clients. Yeah, also we do some innovation. As you can see, we have a onshore simulation center in Kaohsiung too. Okay, here is the progress, yeah, about our development for the technology. We began from a very small vessel. The length is about 5 meters. Yeah, and we developed all the technology by our own. As you can see, we began from the dynamic positioning system. So with this experience, yeah, we integrate the navigation system, and also we set up the 4G and 5G communication, yeah, with our autonomous boat. And 2 years later, after 2018, yeah, we start to cooperate, yeah, with the operation company in South Taiwan, Kaohsiung. We successfully retrofit uh, few electric boats, yeah, to let it become an autonomous ship. So we expand our testing field from Dancer River located in North Taiwan to South Taiwan, Love River. So the one thing we would like to emphasize on is we began the proof of concept to proof of the service, yeah, verification from 2020 to 2022. Yeah, so from the field, we realized the auto route planning, and also we make the data fusion, yeah, with the camera and LiDAR, yeah, to make a better situational awareness function, yeah, to do the object detection. So also we realized the auto docking function, yeah, from the project. So as I already mentioned previously, that is about the route, yeah, we realized in South Taiwan, Kaohsiung. So the test field Love River and two bridges to cross. And so the testing ship is about 30 meters long and catamaran to propel us. And the seating capacity, by the way, is the ship for tourism application. Is about it can accommodate 44 persons and very low distance. Because in Taiwan, the regulation has not been set yet. I think worldwide met similar issues. So so we limited the testing area, and we make the communication with our government, yeah, to make this testing happen. I think that is a very big progress in Taiwan. Okay, so those are the equipment happening in the shore side. Here goes the experience of testing result for the auto navigation. So as you can see from the testing result, the RMS is about 0.1 kts up to. So the route checking, yeah.
Sorry, Well, sorry for interrupting you. We have all the same slide on the screen.
Oh, sorry.
Thank you. Sorry.
Sorry. So let me quickly repeat the result. Maybe I just mentioned about. Yeah, so I just quickly go with those slides. Yeah. It's about the progress for the auto navigation. The routes we let it move by itself autonomously. So here goes the auto docking function. Yeah, with the radar and camera system. So for our testing result, the LiDAR sensor fusion, we can detect the length about the 68 distance, yeah, for the small vessel. Also the obstacle, yeah, on the sea, as you can see the yellow color, is a kind of border, yeah, on the river. So it's about the collision avoidance. So the speed of our boat from this testing is set to 4 knots. As you can see, the obstacle was detected, yeah, about 70 meters far away from our boat, and we began the function. Then we act, yeah, from 9 seconds, around 8 to 9 seconds later. And finally, we detect the obstacle, yeah, and make the collision avoidance. And then we move back to the route we planned. So it's another case, a moving obstacle, another boat. Yeah. So we already accomplished the field testing plan. Yeah, those are the milestones. Yeah. So what we are going to do for the next step, yeah, is to enhance our night vision. Yeah, it means we had to combine with more advanced sensors with our autonomous boat. So in Taiwan, maybe as far as I know, maybe in Hong Kong or some other country, all of them have something like the sandbox projects. So with the sandbox project, it allows us to make the test. Yeah, with the permits from our government. Yeah, it's very important, yeah, for the innovation for autonomous ship. So in Taiwan, we follow this rule to make the new development for autonomous function. We hope to expand our testing field from the river to offshore open sea. Yeah, maybe just step by step, because we face the challenge for the communication from satellite, because the bandwidth is too small, or the expense is high too. Yeah, so we hope to break through for the coming few years. Yeah, with more and more low Earth orbit, yeah, satellite was available, yeah, from the market. So here is the summary, yeah, including the challenge we face right now, and also with the progress. And once again, yeah, sorry for our late coming, yeah, because the issue of connect. And thank you for your attention.
Thank you very much. It was also very interesting opinion and presentation of the technological ideas, and especially on the experimental stage. So we can see what are the phases, what are the stages of the introduction of the new technology It was very practical and very interesting. Thank you very much. But before I thank you once again, shall we hear if there are any questions from the audience? If the participants would like to ask you some questions, maybe give some comments to the presentation. So please, we see some, yes, in the chat box. If you can see, that's the question in the chat box.
So the question is, have you simulated equipment failure on the control center side, vessel side, or telecommunications side? What is the response of that vessel? Okay. Yeah, of course, because as everyone knows, it's before we make this system become reliable. Yeah, we will face the challenges. For instance, yeah, when we try the 4G and 5G communication, yeah, with the application for the autonomous ship, yeah, it highly depends on the telecom supplier availability for providing the strong connection. Yeah, so normally if without the connection, yeah, it means our system, yeah, will has risk to meet failure. So firstly, we have to enhance the connection. Yeah, so we request for providing better service from telecom company. And in the meantime, yeah, when we are design our systems, we will not just use one kind of equipment to design our system control function, as well as we won't do that. Yeah, with only one set of the perception function. We always design for the system redundancy, yeah, to prevent maybe just the impact from the connection. Yeah, thanks.
Thank you. Right. If there are any other questions, to a speaker. One more question. Collision avoidance. Is it all the artificial intelligence making decisions, or the operator of the control center will take over? What is your opinion, please?
Decisions. The answer is no, because we began from the remote control system firstly, yeah, prior to just apply it to let it go autonomously. Yeah, because as I mentioned, the redundancy for the system is important. Also, how to make sure all of our testing within control and is a very safe situation is our another concern too. Yeah, so that's why we began from the remote control. And once we make the system goes well and more stable, we change it to the autonomous mode. Yeah, and yeah, another question: will the operator for a control center will take over? Yes, no doubt. Yeah, because it just designed for system redundancy. Yeah.
Thank you. Dear colleagues, do you have any other questions? Or we can also ask somebody from Philippines to maybe to comment, to give their opinion on the situation, on the implementation of the autonomous ship and autonomous navigation. Because I think there are some questions from Philippines, and it will be very interesting to hear also your opinion about the introduction of that new technology. Probably the floor and to comment, to give his opinion, please. Okay. I'm sorry because the representative of Indonesia, she is not yet with us, so we can now probably ask the second question from the team. You will ask the second one.
Yes, dear participants,
Question.
I'm going now to share another question in the chat, and we kindly ask you to answer this question. Thank you so much.
It's about what? It's about
The question is, do you think the trial projects on autonomous navigation would be beneficial for your country if implemented together with a country that is already advanced in implementation of such technologies? What other stakeholders should be involved in the trial project? So if anyone would like to share its opinion now, so you're very welcome. You can just take the floor, or you can answer following this link in the form. Thank you.
Thank you, thank you. And as due to our schedule, I will now ask you probably to take the floor just to present some results of the project.
Thank you so much. In just a second, we're going to share the presentation.
Конечно.
So, dear participants, I'm going to briefly present you the recommendations that is part of the study report on access to the autonomous navigation technology that was developed jointly together with member economies taking part in the project on international cooperation on autonomous navigation to promote safe, efficient, and sustainable maritime transport implemented under APEC. The recommendations were prepared with the aim at supporting selected economies in Asia Pacific to strengthen their capacity to effectively implement autonomous navigation technologies. While the study report itself was prepared with aim at raising awareness of relevant stakeholders about benefits and recent developments in autonomous shipping technologies. And taking this opportunity, we would like to invite all participants to provide their comments and suggestions on the study report or any recommendations, if any. So you can submit to us, to the project oversee team until next month. And we will incorporate all your comments in the final version of the study report. Next slide, please. And now I'm going to present you the main components of the recommendations. To strengthen the Asia-Pacific capacities in implementing innovative autonomous navigation technologies, a comprehensive approach is required that addresses key factors, such as a regulatory framework that should be developed and established to address legal and liability issues associated with autonomous shipping technologies. This should include a regulatory framework for trials and implementation of autonomous navigation, guidelines and standards for autonomous vessel design, operation, and maintenance, as well as regulations for data privacy and cybersecurity. Another important component is funding for research and development that should be encouraged to support the innovation development and testing of these technologies. Partnerships between industry and academia should be established to develop and test new technologies. Another important component is infrastructure investments that may include the development of the autonomous ports, establishing trial routes, shore-based control centers, and communication networks to support the operation of autonomous vessels. Development of the skills and knowledge is of great importance to effectively operate and maintain these technologies. Training programs and new simulators for seafarers, engineers, and other stakeholders should be the part of government plans. Public engagement is essential to build support for autonomous shipping technologies. Public consultation, stakeholder engagement, and communication campaigns should be conducted to raise the awareness on the benefits and risks associated with the technologies. Awareness raising is very important to promote the application of autonomous navigation, sharing best practice examples, organizing awareness-raising workshops and seminars to exchange the information about recent developments, benefits, challenges, and ways to overcome them in implementing such technologies would be beneficial for all the relevant stakeholders and decision makers, including maritime authorities, ship owners, shipbuilders, and other relevant companies. Trial projects in a real environment, including establishing trial routes, are crucial for obtaining comprehensive experience and access to this new technology. Partnership between various stakeholders and economies should be promoted to test autonomous vessels in different operating conditions and assess their performance and safety. These trial projects would greatly support the development of regulations and standards required for the widespread adoption of autonomous shipping technologies. In addition, to have a common denominator for benchmarking of autonomous navigation within the APEC members, several key performance indicators are recommended to introduce. The list of suggested KPIs should include the following: number of domestic programs to support e-navigation, number of private non-governmental projects to support e-navigation, number of e-navigation experiments conducted, number of ships involved in e-navigation projects, private investments into e-navigation and government investments as well, number of ships using e-navigation systems. To facilitate this process, it is important to promote active cooperation, sharing of experiences and technologies among economies in the Asia-Pacific region. This can be achieved through capacity building, joint research and development efforts, as well as trial projects and practical implementation of new technology, including training, shipping, and shore infrastructure. By working together, the Asian-Pacific region can ensure that all economies have equal access to the latest advancements in autonomous navigation technologies and promote the sustainable growth of the maritime industry. Thank you. And now I'm going to share with you another question in the chat. It's very important for us.
I'm sorry, maybe sorry to interrupt you, but probably our participants will first have some comments on your report, on your speech about the recommendations. Maybe there are some suggestions just now. Probably somebody would like to know what are the purposes of recommendations, how it will be used, and so on. If you have any questions, you are welcome. Not for the moment. So I'm sorry, please continue with the question, maybe.
Yes, and just to answer your question about the purpose of the recommendation, I would like to add that the recommendation has been developed with the aim at supporting countries in implementing autonomous navigation technologies. And now I would like to share with you the third question in the chat. In this question, we would like to ask you to prioritize, according to your point of view, all these components, recommendations that I just shared with you. We would like to prioritize them as you think for your country would be feasible to focus on them. So, for instance, maybe you think that for your country, first priority would be development of regulatory framework, or maybe you need to advance your infrastructure, or maybe you already started to implement these technologies and you need to focus on development of skills and knowledge sharing. So following this link, you will find the form with this question, and we can ask you to make priorities among all these components presented. So, and this your feedback, we also ask you to indicate your economy. This is will be very helpful for us to include your feedback to our final version of the study report. Thank you so much.
Thank you. Thank you. It will take, I think, half an hour to think about, because the question is too complicated and the complex one. And from my point of view, I would prefer to mark all of them because they can, in my opinion, they can be developed in parallel. synchronously to some extent, or maybe something really can precede the other ones. It depends on the situation. And so it will be very interesting to see how our participants and colleagues see that situation of development. Pre-development of the project. Thank you. If nobody, probably anybody wants to comment from the microphone, not in the written form, but probably somebody would like to share his thoughts or maybe doubts or maybe some suggestions just now during our discussion. It's a good way to share the views with the colleagues. No questions in the chat box. If there are no questions now, probably you are thinking about the answers to the questionnaire, because the questionnaire is really rather complicated and needs to think about. But what can be said about these main components, they were also mentioned in the presentation of Ekaterina recommendations. There are some blocks which are important in recommendations. I think that is some cross connection between the question and what you have already heard, not only from Ekaterina, but from all our speakers and presenters today, because we mentioned communication problem, we mentioned research, we mentioned training, we mentioned especially public engagement and infrastructure, not only infrastructure, but also technology development. And we had three, I think, 12 projects today concerning the implementation. All the projects have their own properties and have their own features, but all in all these projects are interesting for the simultaneous implementation of the technology, of training, I think, and communication and technology. And it's also we spoke today of the regulatory framework, which is very important. Probably at national level it can be different, but if we speak about deep sea, about the communications, even communication with the sea at sea and with the shore, there should be some international regulations. This mass code that Alexander mentioned earlier today, it's very important to have, I think, the common environment for developments. But in any case, there are all the opportunities to develop autonomous shipping just now. And the question was, what prevails, what is more interesting now for the participants? Sorry for this lovely comment, but it just to give you a free opportunity to fill in your questions while I was speaking. So, thank you. And probably we can now ask another question.
Yes, we have 2 questions left, and those questions actually we would like to collect your feedback about organizational matters of this workshop. They're not related to autonomous navigation, it's just organizational matters. So the question 4 I just shared with you in the chat. And now I'm going to share with you the question 5. So in total, we have 5 questions prepared for today. And we would very much appreciate if you could answer all of them. So the fourth question is about timing, if the proposed timing of the current workshop was convenient for you. And the question 5, you would like to understand how useful this workshop was for you. If you learned something new, if you got some new ideas, new information on autonomous shipping. And also taking this opportunity, we would like to thank you for your active participation, and we are glad to see that our workshop generated so many questions from your side. We are very glad, and all your questions and responses will be also included in the final version of the study report.
So I think that all the participants they can also forward the more longer comments and probably suggestions for the report, for the recommendations. Yes, you can show probably in chat box the email address. Probably it will be useful. The participants, if they will have any questions that can help all of us to promote the autonomous shipping and to get formulate the report. And I think probably we can think about sharing the results of our questionnaire related to the participants. If you have the emails, we can move forward for the results. It will be interesting not for somebody, but for all of us.
Yes, of course, we will share the final version of the report, of the study report, and we will incorporate the whole section dedicated to the outcomes of this workshop, also today's workshop and the workshops that we held on 13th of June. So we will share with participants all that information.
Thank you. Thank you. I think it will be useful. So, dear participants, as we did not have two speakers today due to some technical problems and the schedule, so I would like to ask you once again if you have any questions, maybe comments or something like that, because it's a good opportunity just for us to hear each other, not only to exchange the documents, but also to speak here with us. Please, so you're welcome to speak, to give the comments you want, and to ask the questions to the participants or to today's speakers. Please, be welcome.
So we have now another question in our chat box. Can we have a copy of the PowerPoint presentation of the speakers? Yes, of course. And if you would like to get a copy of the presentations, please send the email to the email I just shared with you, which is ekaterina.malatsova@aenow.org. So we will gladly share with you all the presentations. And if you have any questions, comments, suggestions, please just reach us out and we will be glad to stay in touch with you. Thank you.
Okay. So if the agenda now is filled by us, so thank you once again for all the participants, for the speakers, for the participants, for those who asked the questions, and to those who answered those questions. So your contribution is very valuable for the progress of the project, for the reported recommendations, and I think that you will have the possibility to continue your cooperation and interaction with Ekaterina and with the team later on. If you have any questions, you are welcome. And from our part, we shall share with you the PPT and other documents that will be finalized thanks to your participation and thanks to the opinions that we had today. So, dear colleagues, thank you once again very much. And Brian, I think that we'll have other opportunities to meet and to discuss urgent issue and so important for the technical development of shipping as autonomous shipping. Thank you once again. Good evening and till other meetings. Thank you. Thank you. Thank you very much and bye.
Bye.
Thank you. Thank you once again. Хоть вопросы бывает, что задать, когда основной учесть. Бывает. Ну все, давай. Спасибо.